Hello everyone. Today our topic is how to convert column types into dictionary using function called dict of df.dtypes. So here first we'll see what is the df.dtypes. So I already made one video on this topic, how to use df.dtypes. So you can see this particular video in my PySpark basic playlist. So df.dtypes, it returns a list of tuples where each tuple contains the column name and its corresponding data type of the data frame. And if you see the tuple, what is tuple is? So tuple will be like at starting and ending with parentheses, and inside that first will be like column name, and second thing is like data type of relevant column name. So this is the output we'll get like this. And if you see example like if you pass df.dtypes on any particular data frame, so you will get output like this. So if you see here starting and ending is square bracket, so that is list. So that is list. So list of tuples means, so inside list you will get multiple tuples. So this first tuple is related to first column. So the first column, so that is this one, first column name and relevant data type. And second tuple, it belongs to second column. So that is, this is second column name and relevant data type. And third tuple is, this is related to third column, that is category and its relevant data type and so on. So this is about df.dtypes. And next we'll see on top of this df.dtypes, I'm applying dict function. So that means what it happens is dict constructor transforms this list. So that means this list into a dictionary where column names are keys and data types are values. So that means if you see here, this is starting and ending is list. And as soon as you apply this dict function on this, what it happens, it will convert to dictionary. And if you see here, starting and ending is flower bracket. So that is a dictionary. And inside that, you can observe key value pair. So this first key value pair is related to this one, first tuple. So this tuple is converted into key value pair. So the same thing you can see here where column names are keys. So that means this is column name. So here, this is column name. So here, since it is a dictionary, this is key and this is value. So column names becomes key and data types becomes values. So that is this one meaning. So next one, first it is a list of tuples that it converted to dictionary, and after converted to dictionary, we can access those values. So like this. So first here what I'm doing, this syntax like dict of this one, I am defined to one variable, that is d type underscore dict. So on top of this one, so that means this particular output is this one, dictionary, this particular dictionary. So on top of this, we know that dictionary we can access by using different methods. So in that, one of the method is index method. So here what I'm giving index is, in index I'm passing the key value. So that is this one. So this is the key I passed here. So if I pass key here, what I will get is, I will get output as value, that relevant value I will get it. So since this is key, this relevant value is string. So the output I'll get string. So this is the main purpose of doing this dict. So that means first list of tuples that converted to dictionary. After converted to dictionary, we can access those elements by using this dictionary index method. So now we'll see with one example. So here, this is my sample data frame. If you see here I have this many columns here. This many columns I have. And in this, we have different data types also. So df dot print schema. If I print this one, so here it will print schema also. See here, we have date data type and string. See here, we have many strings are there and integer is there. So total on average, we have four data types. One is a string, date, string, integer. Okay, three data types we have. So total we have this many columns, and among this we have three data types we have. So on top of this, what I'm doing, I'm adding few metadata columns. So the metadata columns are like, what I'm doing here is, first I'm adding one column, and if you see the result here, up to here, this is related to our sample data frame. And these three columns are our metadata columns. So on top of sample data frame, I'm using with column method, and my column name is load underscore date. So this how I'm generating is this load underscore date. Here I'm using PySpark function, that is current underscore date. So what this function does is it will print today's date like this in this standard format, like year, month, date. But since I passed function here, that particular value it applicable for entire column. So this is like constant value. And at the same time, I'm adding one more column, that is load underscore time. And here I'm using function called current underscore timestamp. So that means here it will add timestamp value. So timestamp means first date. So this is the date, year, month, date, and in between T and here time. So what is time here? Hour, minute, second, millisecond, and time zone. So this is timestamp, and you can see data type also here date and here timestamp. And I'm adding one more column, that is current underscore user. So we have function called current underscore user. So here it will print you your username here, either mail ID or username. So whatever you provided in this Databricks uh, account. So here what I will do, I will try to add one more column, one float column, decimal values I will add. So what I will do here is I will add with column. So with column, I will add like one constant value I will add. Maybe rating, I will add column name as rating. And here what I will do, I will use a lit function here. Lit, I will write like f dot lit, and I'm passing some constant values, maybe some 15.89 like that. Okay, so if I rerun this one more column will get add here like rating, and these values will be like constant 15.89. So here rating column is added with 15.89. So now here again I will uh, print schema because I added few more columns. So I want to check, I want to print those columns also. And if you see last four columns, these are all the four columns added as metadata columns. So those columns are, one is a date, timestamp, string, and one more is double. Now what I will do is First, we'll see what is df.dtypes. So we know that it returns a list of tuples. So, and in that each tuple will have details of column name and that relevant data type. So if I rerun this one, because I added few columns, so it is updated here. And if you see here, starting is square bracket, that is list, and inside that we have tuples. Each tuple is belong to each column, and the column name is this one, and relevant data type is this one. And the last column I added is that is rating, and that relevant type is data type is tuple. And similar way, we can print this data type also. Like, so here by visually I'm telling like list of tuple. So what we can do is print the type, print the type of df.dtypes, df.dtypes. So print type. Okay, so print type of df.dtypes. So df.dtypes means this one, this result. So this result data type is telling that. So that is list. Okay, so now next we'll see this list of tuples how to convert to dictionary. So what I'm doing, we have function like dict function. So I'm applying dict function on top of this df.dtypes. So what will happen? This list of tuple is converted into dictionary. And if you observe here, starting and ending is square flower bracket. So that means that is a dictionary. And inside dictionary, you can see key value pair. So this is first key value, key, and this is first value. So this is one key value pair, and this is second key value pair, and this is third key value pair, and so on. And if you compare here, after converting this first tuple, so this first tuple is converted into key value. So this one, key value. And here, column is this one, start date. And this is the data type, date, start underscore date and date. So start underscore date, here it become key, and the date it become here value. So similar way, we can print data type of this also here. So earlier it is list, earlier that is list. Now we'll check this particular thing, type of this. And if you see here, we'll get dictionary. So earlier it is list and now it is dict. Okay, so now we converted to dictionary. So after converting to dictionary, how to access the values of each key? So in dictionary, we have multiple methods to access the values. And I already made one video on how to access dictionary values. So if you see in my Python playlist, I made few videos on different videos on dictionary. So if you watch that video, it will be easy here to understand this one. So now what I'm doing here is I wanted to show you how to access the values of dictionary. So now my input is this one. This is dictionary. So from this dictionary, I want to access few values. So first this dict df.dtypes, I defined one variable that is column underscore dtypes. So now this column underscore dtypes is this one, this dictionary. And here what I'm doing, I'm using index method to access the value. So this is my dictionary On top of dictionary, I am using index method like start underscore date. And if you see here start underscore date is the key value, key. So for this key, what is the value? Date. So whenever you write like this, dictionary, these are main dictionary, dictionary of index method is key. If you pass key here, you will get output as value. That relevant value you will get. So this is key, start underscore date is the key, that relevant value is date. So that we are getting here. And next, on same dictionary, I want to access the value for this particular key, that is source underscore target. If you see here, source underscore target, value is string. So that I'm getting here, this one string. And next, on top of dictionary, I want to access value for this particular key. Key name is sessions. So this is sessions and relevant value is integer. So that integer I'm getting here. And similar way, on same dictionary, I want to access the value for this particular key, that is load underscore time. And if you see here load underscore time, the value is timestamp. So that we are getting here. So this is about how to access the data type of a specific column. So whenever you have your data frame, and you want to, if you want to check the data type of any one particular column, what we can do is simply you write like this, dict of df.dtypes, and that variable, on top of that variable, you mention the column name. So for that particular column name, you will get the data type. Okay. So like this, you can verify. Suppose if you give like this, print schema, this it will list you all the columns that relevant data types. So instead of going and checking each and everything like where this column comes and relevant to data type, what you can do is simply you can write these two lines of code like this dict df of d types. And for this variable, if you mention the column name, you can directly, you will get the data type of that particular column. So next one is how to get all columns of a certain data type. So that means in any of the data frame, different columns will be having of different data types like integer, string, date, timestamp, double, uh, maybe different integer data types like double, float, long type, big int, like this. So I want to filter some different data types. Suppose from sample data frame, suppose I want to filter out only string columns. So for that, what I can do here is, so in my first case, so here what I want to do is, I want to display only string columns, or otherwise all string columns. So if I want to display, or if I want to get the list of all string columns, what I can do here is, first I can convert into dictionary df.dtypes. The list of tuples, first I can convert into dictionary. After converting, I need to filter out. So how I can do filter out is by using this list comprehension. So here I'm writing like simple list comprehension, like first D type of dictionary. So that is this one. So what is this output? Dictionary. So in dictionary, I'm using items method. So here, why I'm writing items method is, if you see in our dictionary, so here we have key is there and value is there. So I want to iterate both the things. I want to iterate both the things. Key also I want to iterate, value also I want to iterate. In my first iteration, that is this one. This first key value pair is my first iteration. So key also it will iterate, value also it will iterate. And in second iteration, this particular key value it will iterate. And in third iteration, this particular key value it will iterate. And next iteration, this particular key value it will iterate. So now if you come back here by using items method, what it does is we can iterate both the things as we discussed. Call comma type. That means call means column name, type means data type. So call for, here I'm using for loop, call for call comma type in this items. So up to here, if you see, what you will get here is each and every item, each and every item, that means each and every key value, it will iterate. Suppose if I write this one separately up to here, you can see what it does. So here I'm closing here. So before that, I will define this also. So first my dict df.dtypes means this one. This is the output. So dictionary key value pair. So that I'm passing here. So that is this one, that variable. So dot items. So items is the method to iterate both the values. If I run this one, see here, first one is start date. So if you see here, first one is start date, product underscore URL, category. So why we are getting only columns here is, here I mentioned call for, call comma type in this items. Suppose if I mention type here, it will iterate only data types. Suppose if I run this one, see here, all data types here. So whatever this one, no values, this one. So all this, it will iterate here. So here, what I will do, I will retain again this call, because in our list computation, I given this. So here, up to here, what I'm getting here is, up to here, I'm getting the list of columns. I'm getting list of columns. And on top of that, what I'm giving if condition. If type is equal to string. So here, what is type? So here we are iterating two things. One is column and data type. So suppose in first iteration, it will iterate this. So here in this is column name, this is type. So if this type is equal to string, what I mentioned here is string. If type is equal to string. So in first iteration, it is date is there. So it is not matching, so it will skip. Next, in second iteration, my type is string. So this is matching. So up to here, all strings, it will match. So it will pick these columns. And next integer, it won't match, it will skip. Next, these three string columns, it is matching. It will pick these string columns. Next, these two columns, it will ignore. Next, it will pick this string column. Next, at the end, it will pick this string column. So wherever string is there, value equal to string. So it will pick all those string columns. Here, if you see here, if you print this one, so these are all the string columns. And so here I printed only columns. on top of this, what I can do is uh, df.string I will mention, and our initial sample data frame is df.select. What I will do here is star, and I will pass this string variable here. So now what will happen? And on top of that, what I'll do, display df underscore string. Maybe I can limit up to 5 values. Top 5 values I can limit. So what is happening here is, from my sample data frame, I have many columns here. See here, this many columns here. But among these columns, I'm using select statement. In this select statement, I'm passing columns. Only these columns I want to pass. So that is starting underscore calls. What it means? Only string columns. Among these many columns, it will pass only these string columns. If I run now, our data frame will be only string columns. See here. See here, if you see here, we are getting only string columns. And you can check at the same time, like df underscore string dot print schema. If I run this one, at the end, you can see, like all, if you see, all the data types are string, only string. So this how you can filter our data types based on data type. So here, first I listed down all the string columns, then those columns, this list of columns, I passed in select statement, then I displayed only string columns. Next, what I will do, I will try to display only integer columns, all integer columns. So here what I'm doing, same syntax. Here I'm changing the type. So earlier I given string, now I given integer. So up to here it is same. We saw that already. It will give you the only the list of columns. So on each iteration, it will check like if type equal to integer. So that means from here, first it will iterate this one. Since it is date, it will skip, and up to here it will skip because date string is there. Next integer is this one. So it will select this one, session underscore ID. Next, it will skip these three things. And next, it will select these two integer columns. And okay, so total we have, if I run this one. So now we have here one column and here two columns. So total 3 integer columns will get here. So if I go here and if I rerun this one, I will get these 3 integer columns. And on top of this, what I can do, df underscore integer and df dot select, and I will pass this variable like int underscore calls. So that means here I'm passing integer columns. And again, I'm displaying this up to 5 columns. And later I'm printing this schema to show only integer columns are selected. If I rerun this one, so very first one, print int column is integer columns. So these 3 are the integer columns. What I can add here is integer columns. So these are all the integer columns, that is list of columns. So this list of columns I'm passing here in df.select. So what it will do is these three columns it displaying here, integer columns, and you can confirm these data types here because I given print schema. So what I will do here is here also I will do small change like print all otherwise string columns, or I can say list of string columns. So if I reprint this one, so this text will add here list of string columns and remaining it will be same. And similar way, I will add here also list of integer columns. Then it will update here list of integer columns. Okay, this we saw already. So now similar way, I want to print all date columns. So here also syntax is same, only changing is date. So now what will happen if I go top again to dictionary? So now my type is a date. So first one is a date, it will pick this column. Next, it will skip all the things and it will select this one. So only two columns will get. So date columns are only two columns. So that we are getting here start underscore date and load underscore date. So what I will do, I will add text here like a list of date columns. And what I'll do, I'll display data frame also, only date columns. Okay, so here what I did, df dot from initial data frame, I'm selecting the only columns of this one. Date underscore columns means this one, this list of columns. That means only these two columns. And I limited to 5 rows, that is limit 5. And to confirm, I'm used print schema, and you can see here we are getting only date columns. And at the same time, if you want to filter out only timestamp columns, all timestamp columns, and here what I will do, the list of timestamp columns. And on top of that, I will display the data frame like df.dt equal to df.select star date calls. This date calls I'm pausing and limiting to 5 rows, and I'm printing scheme. If I run this one, so here my list of timestamp columns is only load underscore time. So only one column I'm getting. And to confirm this, you can check this data type. At the same time, we'll see we have one double data type. So I'll copy same thing. So I will change only to double. So instead of timestamp, I will mention here double. And here instead of date, I will mention double. So since we have only one column, so that one column it will show here. So list of this not timestamp. So list of double columns. So list of double columns are only one column rating. So that rating column we are getting, and to confirm that this double. And here we can do one more thing. Okay, I written separately. So we'll see here. So as of now, we saw to filter out all individual columns, all double columns. So next, we already saw about how to filter integer columns. So here, if type is equal to integer, so sometimes what happens, there are chances of having different integer columns. Like I want to filter out all numeric columns. So for that, what I'm doing, this is as usual, same code, dict of df.dtypes, and here also same. So it will give you the list of columns. And here I given condition is if type in condition I given instead of equal to I given in condition. And what is this in condition? I defined one variable here, numeric underscore types. Here I am passing one set. So in this set, what is there? I defined all the types of numeric columns. So sometimes we'll get data type as like int, double, float, long. So I think in PySpark we want to get this one float type. So we can keep it or we can remove that. So but we'll get long data type we'll get. I think big integer and long both are same. I will remove these two also. So these are all belongs to SQL. So three data types I'm passing here, numeric columns. So now what it will happen is it will go, if you go to this dictionary. So first, what is in condition? int. So for int, we know that already we have three columns. And next, what is there? Long type is there. So, but here we don't have any long type. And the third one is a double. So we have one double. So total four columns we'll get here. So these four columns are the all our numeric columns. So if I run this one, so total these four all the numeric columns. So what I will do, all list of numeric columns. And on top of that, what I'll do, I'll try to display data frame also. And df.select, and I'll give this variable numeric calls, and I'll try to print first 5 rows, then I'll print scheme also. Okay, so now if I run this one, first the list of numeric columns are total four columns. So in these first three are integer columns, and last one is double. And same those four columns I am displaying here, first 5 rows. And to confirm, I given print schema, and you can observe that first three are integer columns and the last one is double. Okay, so this is how to find numeric columns. So next, how to select only date or timestamp columns. So here code is same. What is the difference is in condition here I given uh, the integer, double, long, and here I given date and timestamp. Two things I given. So here what I will do, I will add one print statement to display the list of columns. So list of date and timestamp columns. So list of date and timestamp columns. So it will print the list of columns, and at the same time I want to display uh, the data frame related to only date and timestamp, and I limit it to first 5 rows. Then what I'm doing, I'm trying to print the scheme. If I rerun this one, first is list of date and timestamp columns are these 3 columns. So those 3 columns it displaying here. And if you see here, first 2 are date columns, these 2 are date columns, and the last one is timestamp column. Okay, so this is, so next one is, by using this kind of scenario, how to rename the columns. Suppose I want to change the, I want to rename the columns only related to string. So how we can do is, so earlier we saw by using list comprehension here to filter the only string or integer or date or timestamp. Here what I'm doing, here I'm instead of list comprehension, simply I'm writing for loop. So for loop call comma type. So that is this one column. This is the data type, and in this dictionary dot items. So in this iteration, what in first iteration, what it comes is first column and data type it will pick, and I given if condition. So if type is equal to string. So here these 2 lines of code exactly equal to this one string. So wherever string place I return list comprehension, so equal to this one. Whatever I written for loop in there, that 2 lines of code exactly equal to this one. So after for loop, what I given is, I given this one, this condition. So up to here, what it does, for each and every iteration, it will check whether data type is string or not. If that particular column, it is a string, then what it does is df underscore string. That means our original data frame. So original data frame I used with column renamed. So what it does is here call means in first iteration it will pick column, right? That column, and it will rename to upper. So that means in first iteration it will check. That means each and every column it will check. That means in each iteration, it will check whether string or not. If it is string means that particular column, it will change to uppercase. And if you see here, so here I'm printing all the final data frame. But if you see here, wherever string column is there, see here, wherever string column is there, it is converted to uppercase. So earlier, all these are lowercase. Now, wherever string column is there, so everywhere it is converted to uppercase. If I rerun this, it will come this metadata columns also. See here, current underscore user. This is string column. So this also converted to uppercase. So like this, you can change the column names also. Here I changed for string columns. Next, what I'm doing for integer columns. For integer columns, what I'm doing. So string, we have only one type. So here I given if type is equal to string. But in integer, we have multiple data types. So I used in condition. So if type in, I passed a tuple. So in this tuple, like int. The data type may be like int, integer, double, float, long, big int, small int. Maybe you can exclude these three things: float, big int, small int, because in PySpark we don't get this kind of data types. Okay, so what it does is in each and every iteration of dictionary, it will check in first iteration, first column, it will check whether it matches any one of these data type. If it is matching, then what it will do, it will rename that column to uppercase. And if you see here, so wherever integer column comes, suppose here this is integer column, so it changed to uppercase, column name changed to uppercase. And at the same time, so here this is integer column changed to uppercase. This also integer column, that is this one long time, it changed to uppercase. Okay, so similar way you can write condition like if you want to do it for date column, you can change here a date. If you want timestamp, you can change timestamp. If you want to double, you can write double. Or if you want to change all the columns irrespective of data type, then you can remove this condition. You can remove this condition. Maybe we'll try at the end. What I will do, I will remove this condition. So now what happens, df underscore all. So here also df underscore all, and here also df underscore all. So now what will happen, here also all. So now what will happen, since we don't have any condition, so here what it do is in dictionary, by using items method, it will iterate all the columns. So for each and every column, it will convert to uppercase. And if you see here, now all the columns, it converted to uppercase. Now you don't see any single column with lowercase. Okay, so next, how to validate column types before transformation. So first we want to check whether that particular column is belongs to particular data type. Suppose I want to check any one particular column. I will randomly select some column and I want to check whether that particular column is belongs to string data type or not. So for that, first I'm converting this one to dictionary. Now my output is a dictionary, and here I given written condition, if else condition. In if condition, what I given, if this dictionary, here I'm using get method. So earlier I used index method. So index method, how I written dtype underscore dict, and I given square bracket, and inside that I mentioned column name. But here instead of index method, I'm using get method. So in get method, status underscore name. And if you see status underscore name, that is this one, status underscore name, if is equal to string type, but actually it is string. If it is string type, then I want to print like status underscore name column is string. If it is not string, I want to raise error like this. Status underscore name column must be string like that. But since it is string, it will print the statement under if condition. Status underscore name column is string. At the same time, I'm trying for other column, start underscore date. If you see here, start underscore date. So this one. So this is actually date. Data type is a date. But here what I given, string. So while checking an if condition, since this data type is not matching, it will come to else condition and it will throw this error like else rise means this value error it will here. Okay, so this is like randomly checking the data types. Next, how to use it for dynamic casting. Suppose if you want to change the data type, then how we can do it. So this is same and whatever we written code almost same. So this is same sample data frame I define to variable df underscore long, and this for loop is same by using items method, and I given filter condition here if type equal to if type is equal to integer. So what it will happen is it will filter only integer columns. Then that integer columns, what it does is here I'm using with column. So with column is it will change the data type by using this cast method. So with column, I given call. So that means for in first iteration, if data type is matching, that integer column, it will pass here column name, and that column name call of call. So call of call. So that particular column I am converting to long type. So we know that we have three integer columns in this data frame. Those three integer columns, it will convert to long type. To confirm what I will do, I will print scheme also here. So if I rerun this one, it will add print scheme also here. So here, so if you see here, where is our integer column? This one, integer column. If you see here, earlier it is int, now it is big int. And one more is this one, impressions. Earlier it is int, now it is big int. And product ID, earlier it is int, now it is big int. So this total three integer columns, now it converted to long type. If you see here, session ID, now it is long type, and sessions product ID, now it converted to long type. So like this also you can convert the data types dynamically. And next is same thing, same syntax. So wherever date type is there, it will filter the date data types, and that particular columns, it will convert to timestamp. And if you see here, total how many date columns we have, this is one start underscore date, and we have one more load underscore date. So we have two columns. And if you see this one, start underscore date, currently we have date values here. And one more is load underscore date. So this is date column. So only date values is there. Now what will happen? After applying cast to timestamp, you observe here, this converted to timestamp and values are converted from date to timestamp. And similar way, load underscore date also, it converted to timestamp values. So here what I will do, I will print schema also. So we can see here like start date, start underscore date, it converted to timestamp, and load underscore date converted to timestamp. So next, use it to build a schema summary. So if you want your customized way, then what to do? So this code is same to convert to dictionary. So here I written for loop by using items method, and in print statement what I given like this call, first I given call and semicolon 20. So this call, what is that? In each iteration, it will pick call, right? So that is first column. So that is start underscore date. and this semicolon 20 means spaces. So these many spaces. After that, I give an arrow mark, and after arrow mark, I want to print the type. So here, what is type? This particular column relevant data type. So for each and every, if I update, it will add this metadata columns also, these four. Okay, so these are all the different scenarios uh, to apply this dict function by using df.dtypes. So that's all about this video. If you really like this video, please like and subscribe. Thank you.